Okay, here's a question, a simultaneous equation question. You can spot it by the fact there's two equations, and it just asks you to solve, basically, so you're finding values where they're both true. I'm going to have a little bit of explanation on this. This will be a circle because it's got x squared and y squared there, plus y squared equals 18. And then there's a line. So this second one here is a linear equation because there's no squares. And so this line, you're finding the 2 points where they both cross. So, but you don't need to worry about the graph or anything, I'm just showing you. And just another point on circle graphs, there's always x squared plus y squared. And this equals 18 is the radius squared. So the radius will be the square root of 18. There's a little bit of information on those. So simultaneous equations, just close on this one. So what you have to do, the first step is what you have to do is to arrange the linear part into x or y equals. I'm going to make it x equals because it's easier. X equals, and then I'm going to plus 2y to both sides. And I've created another equation. Okay, and it's the same. Basically, it's just rearranged. So these are the same, just rearranged. Now what I'm going to do is substitute in 3 into 1. Okay, and I'm doing that so that what happens, I'll show you what happens. This x value, instead of there being x here, I'm going to replace it with the value of x from this one. So the x becomes 2y minus 3 all squared plus y squared equals 18. And then common mistakes here is to just square both of these, even though people know that's not what it's just kind of what you, because you've got so much going on in your mind about what we're going to do next, you forget that this isn't, you're not just squaring 2y minus 3. I would always, if I see that, I would actually physically write it out twice. Because remember, all those values are timesing with the other values. It's really important we don't forget that, because otherwise it will all go wrong. So 2y times 2y, 4y squared, minus 3 times 2y, minus 6y, minus 6y again, and then plus 9. Again, another common error, because you've got so much going on, is forgetting the two negatives equal a positive. Okay, so I've just literally written all that out again. So this first 4 terms is just this part expanded, y squared, and then 18. It's just this part kind of here. Okay, just kind of separate out. So you rearrange it to form a quadratic. We're going to have a quadratic here. So 5y minus 12y. Then I've got a plus 9 here, and then I'll minus the 18. I'll bring the 18 over so that we're left with minus 9 equals 0. So what this tells us is where they cross. Okay, my method of this is this square off there, sorry. This is a quadratic, and it's a harder quadratic, which means it's more complex. It's not just y squared; it's 5y squared. I use this cross method. Now you can use whatever method you there's something called a squiggle method that people use, but I like this one. You times this first, whatever is in the a, if you like, 5, and the c, so a times c, so it's 5 times minus 9 to get minus 45. Then we pick up this number in the middle, minus 12. And the reason we've done that is just I need to find, this is where the two numbers come into it, times to get this number and add to get this number. So they're two negatives, so you have to think about what that means. Well, it means that this one has to be positive and negative. One has to be negative because it's a multiplication of a negative, so they have to be one of each. Okay, so maybe start thinking about what multiples of minus 45 you can have, and they add to get minus 12. If you think about 45, you've got 15. Yeah, so 15 times 3 gets you 45. And then in what way can you make that minus 12? Well, if it's minus 15 and positive 3. Okay, and what I do is I put them in the either side of this little dot up little grid thing that I've made. Minus 15 and 3, and then you'll put it all over the 5. That is, and it's the same as the y squared, or if it's x squared or whatever, and reduce them down as if they are fractions. So this one will become minus 3 over 1, and this one stays the same. And we then can put it into brackets, and the denominator is the value of the y, and then the numerator is the number. So that's just 1y minus 3, and then 5y plus 3. Okay, that's our factorised quadratic. And then to make them force, what does y have to be so that this equals 0? Well, y would have to be 3 in this case, and then y would also have to be, minus 3 over 5. So you've got two values here, because there are going to be two coordinates in our where this can come from. Oops. So substituting now, I'm just going to change my colour. So to substitute in this y value, I'm going to use the easiest one I've got, and that will be x equals 2. You can use any of these equations, but you'd never use the quadratic one, you'd always use the linear. X equals 2y minus 3. Okay, so we know y is 3, so when y is 3, what is x? Okay, so that makes 3, 6 minus 3. That's a nice easy one. And then the other value, this is going to be slightly harder, we've got fractions at play here. 2 minus 3 again, so we're going to replace the y with those 2 times minus 3 over 5 minus 3. 2 times minus 3 is minus 6 over 5 minus 3. And then we just change that to, let's make it a oops, excuse me, let's make it decimal, 1.2, because it's a whole 1 and then a 0.2. Minus 3 equals minus 0.2. Okay, so that's the x values. Got two y values and two x values. So to conclude, I've got two coordinates, 3 and 3. And then my second coordinate is going to be minus 4.2. And if I just convert this one to a fraction as well, it's 0 minus 0.6. Okay, I've seen it quite a lot actually, where they have one kind of straightforward y and x value, and then one slightly fractional or decimalised one. So don't worry if it does go into decimals. This is a harder question. It is at the back end of the paper. You are expected to be able to deal with fractions and decimals. So yeah, don't let it scare you. Just keep going. Okay, and that's the video on that. Any questions, please do not hesitate to ask in the comments below. Thank you.